Type 3 problem. Please try to understand the problem first. Already we were discussing with respect to individual and discrete in detail. And whenever we're discussing both the problems, we were also saying that continuous will be something like grouping, like in terms of class interval. Okay. What happens here is probably what is the lowest mark here? Please, can you please join? What is the lowest mark here? Lowest one, highest 100. Okay. How many observations we have? 90 or 91? 3 in the mind, 7 in the finger start பண்ணிருக்கீங்களா? ஐயோ நடுவில் மிஸ் ஆயிடுச்சு. திரும்ப ஃபர்ஸ்ட்ல இருந்து ஸ்டார்ட் பண்ணுவோம். I think 90. 90. So, what has happened before? Let me go with the definition of statistics. Yeah, please join. Make it faster. How you define statistics? Hmm. First, collect data. How did I collect the data? I kept a test for how many marks? 100 marks. Because I have the class interval spread over to 100. 91 to 100 is my last class interval. So I have the highest mark as 100. So I have conducted a test for 100 marks. And have corrected the paper and have collected the marks. Okay. What's the second step? Classification. What are the different types of classification we have? 4 types of classification we have. What are the 4 types? Quantitative, qualitative, geographical, chronological. What type of classification is this one? Quantitative. See, when we talk about mean, median, mode, and other things, it's going to be quantitative one. For qualitative, chronological, and geographical, we'll stop till bar diagram itself. We cannot proceed further. For graphs also, we need to have two-dimensional figure, which means two-dimensional mathematical value. So here we have classified in terms of class intervals, right? How the class intervals are spread over here starts with 0, 1 to 10, then, yeah, please, 11 to 20, then 21 to 30. Likewise, we have till 91 to 100. This is how we have classified. It is quantitative in nature. What's the third one? Then I have tabulated. You cannot directly tabulate. Instead, what we'll do? See, we have representation. One is descriptive representation, tabulation, diagrams, and graphs. This I have taken with respect to tabulation. See, this is a table, right? It's a table, right? Okay. Tabulation, how I do it? Using the frequency distribution format. How we'll do that? Using tally marks and tally bars. Remember? Then we have to go for analysis and we have to go for interpretation. Analysis, we are going to find everything. Mean, median, mode, everything we are going to find. Okay. I just want to link this. Instead of tabulating, if I have done with some diagrammatic representation, not graphical I'm talking about, graphical we'll do it later. What is graphical representation? 3 things we'll do. You remember? Under graphs. What we do? We turn on the last topic, the previous topic. This is the second topic in statistics. I'm asking you to refer the first topic. First topic is statistical representation or statistical interpretation of data, right? It has something called as frequency distribution, something called as cumulative frequency, and what type of graphs we have here. We'll do 3 things in graphs. What are the 3 things? Yes, you have chosen the right page. Histogram, frequency polygon, and frequency. Yeah, fine. So, those 3 are graphical representations. But what I'm going to do here is I'm going to go for some small diagram to understand it a better way. What's the least mark I have? 0, 1, 1. And the highest mark I have? 100. If I try to plot this one, probably it will look all scattered. Am I right? In case, if I take as graph itself, x-axis and y-axis. What are the marks? 1, 2, 3. Okay, up to 100. If I take this way, all the values will be scattered, right? Instead, for 0 to 10 values, I'll make it as one group, one cluster. Okay, why we do that? Because everything is going to tend to one single value only. That's the central tendency. So instead of taking as 1 to up to 100, let me redefine this as 1 to is 0 to 10, 10 to 20, 20 to 30, but actually it's given 1 to 10 and 11 to 20, but usually we take it as 0 to 10, 10 to 20 and so on. So 1, 2, 3 up to 10. Instead of defining so many centimeters, what I'm going to do here, I'm going to take only 1 centimeter. This is how you do the graph, right? You remember how we do the graphs? Yes, please join. How we do the graphs? Yeah, please join. We take this like this way. We'll take x-axis. We'll take y-axis. Then starts your origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And how many students are falling in this range? Only 3 students. Instead of doing all this, what I'm going to do here is, instead of taking all this, let me take 0 to 10. Then 20, which is change of scale. 20, 30. What happens? Now, for this range, how many students lie? 1, 2, 3. 3 students lie. So, I'll be plotting my point here. Instead of plotting so many points, I'm going to plot only 1 point. Instead of having so many values in x-axis, I'm going to have only 1 centimeter for 10 units. Okay, so this why we do this is for two reasons. One is the range. What is the range? Highest minus the least value. 100 minus 1. So how the value is spread over? For 99 units, it's spread over. I cannot have the graph extending to 11, 12, 13 up to 99. It seems to be a lengthier one. So to avoid this, we do it. And second reason is, what is the total frequency? It's 90. Again, total frequency 90 means for 90 students I have to do it. At least I'll have 90 columns. So why I need to extend so much? Okay, so for these two reasons, what we do is, instead of going for discrete, we go for continuous series. That is, we make it as clusters. So if I do this in clusters, instead of having so many points like this, what I have now here is for 1 to 10. This is for 1 to 10. Okay, next cluster will be for 11 to 20. Next cluster will be for, okay, please try to understand. I'll be having like clusters and clusters, which means grouped and grouped. At last, everything will be tending to one single value, and that value will be called as the what? Mean or median or mode. Measures of dispersion, range or quartile deviation or mean deviation or standard deviation. So instead of having like single points scattered over, I'm going to have group of values scattered over. But here I'll not take 1 to 10. Here I'll take 3 students. Here I'll not take 11 to 20. I'll take instead, I think 7. Am I right? 7. 7 students. Okay, so this is grouped for 7 students. This is grouped for 3 students. And everything will be tending to a center value. Can you guess what would be the center value? Which means roughly, see in the table. Can you guess what would be the mean, median and mode? Yes, tell me what would be the mean, median and mode from here. Roughly. Don't see the material. Roughly you tell me. Where it would lie. Don't tell me the value. Tell me where it would lie. Because I don't have an exact point. That's the drawback in continuous. This, there's a drawback in continuous. What's the drawback here? What's the limitation here? You cannot give an exact point. Okay. Come here then. By location method, can you identify which is mode? By location method. 13. Right? Now tell me. By identification method, can you locate which is mode? We cannot exactly locate. There's a drawback in continuous series, but you can identify the class where it lies. Where it lies? The range where it lies. Where it lies? Where it will lie. See, this is the highest frequency. Okay, this is the highest frequency. So where my value will be lying? The modal value, 31 to 40. Where my median will be lying? Now try. Now make a try. What do you mean by median? The middle value. How we did with discrete and continuous series? How you find the median value? We find size of n plus 1 by 2. Yes, roughly guess. Where it will lie? What is n here? 90. 91 by 2. It is 45.5. Now tell me that line. 10, 23, 40, 52. Wow. So somewhere it will lie over here. Am I right? See, I have to get the value. See, you remember the CF greater than n plus 1 by 2 value? So same thing we are doing here. So where it will lie here? Somewhat above 45. Here it is 10, then 23, okay, 23, then 40, then 52. So somewhere it has to lie over here, it will lie over here. Okay. One second. Tell me where mean will lie? Where mean will lie? Where mean will lie? मैं class level करेंगे. See, one thing please understand, whether I ask as mean or median or mode, it has a common one term to represent. What is that? Measures of measures of the other word for average. Central tendency. So where it has to lie? Somewhat in the central valley. So definitely it will never lie over here. Am I right? Definitely it's not going to lie over here. To be very exact, it's going to lie over here only. You agree with me? It's going to lie over here only. And because the highest frequency is over here, I can somewhat say this is the class where I can get the modal value. That's why you call this as modal class. You call this as modal class. So probably now leave off mode. Come for mean and median. Again, they are nothing but measures of center tendency. So where it will lie? Leave off these two. So it's going to lie somewhat over here. Is it okay? So this is how we can easily guess. And when we go for median, no other go, we have to use the complete formula because mean is a beautiful measure where all the values will be taken for consideration. Whether it's negative, it will be considered. Whether it's zeros, it will be considered. What about median? You need not consider the n values, where it will lie, middle. Using the formula CF greater than n plus 1 by 2 will utilize it. The only change in the formula for median here is will not use n plus 1 by 2. Instead, we'll use n by 2 itself. That's not going to make a big difference, but still we use n by 2. Okay. Okay, fine. So we'll go for the problem. What are the things you have to make a note of? Obviously, you are going to work out the problem. It's a lengthy problem only, but concept-wise, a few things need to be understood. So let me go for the problem. Yes, please join what we are going to do here. First step, very first step. Please join. You can write along with me. First step, take it as a note. We are going to do all these, okay? After that, you can write the question. Take this as a note. First one. Yes, please, online. You have to check whether class boundaries are given or class limits are given. Usually, we have to do in class boundaries only. Tell me, class boundaries are given or class limits are given? What do you mean by class boundaries and class limits? If there is continuity of interval, we'll call it as class boundaries. If it is jump in the intervals, we'll call it as class limits. If you keenly have a look, from 10 it is jumping to 11. So class limits are given, class boundaries are not given. Okay, so I have to make this as class boundaries. How you do it? My first one is this way, right? What's the difference between the value? 1, which is 11 minus 10. 1. I have to share between the two intervals. So divide by 2. So how much is the value? 0.5. To this, I add 0.5. To this, I less 0.5. So now my class interval will be now 0, 1 to 10.5, 10.5 to 20.5, 20.5 to 30.5. Is it so? Am I right? Huh? Ah, this is not right. Okay. Anything else? Anything else? This is one change she noted. Okay. Anything else? Okay. If I extend in the same way, probably Let me write it. It will take a lengthy time, no issues. 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, 70.5 to 80.5, 80.5 to 90.5, 90.5 to, how do I know? How do I know whether it's 100? I don't know. Okay. How do I know whether this is 20.5? I calculated only for these two, right? Which I'm making a tick mark. How do I know that's 20.5? How do I know this is 20.5, 30.5, 40.5, and so on? Check here. Oh, last video. Check here. 20, 20.5. Sorry, 20, 21. So the difference is 1. Okay. So divide by 2, zero point 0.5. So here add zero point 0.5, here less zero point 0.5. Likewise, if you go throughout, you will find that the intervals are regular. See how much is the difference? 9 values, right? 70 minus 61, 9. 80 is all same. And moreover, we'll check here 70, 71. 80, 81. Same difference. So you need not calculate the boundaries for each and every interval. You can directly fit it. So this is okay. Now tell me why I have to write this as 100.5 and why I have to write this as 50.5. Sorry, 0.5. Actually, it's a limitation in statistics. This is a basic assumption we have to make it. If I take this way, okay, what's my class range? Class range means difference between the highest value and least value in this range. What's the class range? 20.5 minus 10.5. What's the value? If I take over here, what's the class range? 10. If I take over here, what's the class range? So throughout I'll get it 10, right? So I make a basic assumption that for this also it's going to be 10. And also here also it's going to be 10. If this happens to be 10 means what should be this value then? 100.5. If I want this value to be 10 means what should be the value over here? 0.5. So I have to make as a uniform or even class interval. So it's an assumption only. So that's why when we go for finding the measure of dispersion, first one, range. What's the range? Highest minus least. If I go from the original question, what's the range? 100 minus 0, 1, which is 99. If I make some changes like this, like converting limits to boundaries, what's my range here? 100.5 to 0.5. What's the range? This is always a confusion only. That's why range is not a good measure. Instead, standard deviation will be a good measure. Okay. See, if I take from the original question, I'm getting 99 as the spread over of the marks. If I make some small changes, I'm getting 100 as a spread over marks. Definitely is not working out. So we'll not take range for measure of dispersion. So like this, we'll compare. The last table will compare and say that standard deviation is the best measure. So this one you have to make a change. Second one, here the values are spread over. I don't want the spread over of values. I want to have mid values. How are you going to find the mid values? Remember? For example, let me go for this class interval. Yeah, how you find the mid value? That is 30.5 to 40.5. How you find the mid value? Either you can do it in two ways. Either 30.5 plus 40.5 divided by 2 value. Either this way you can do it or 40.5 minus 30.5 divided by 2 value. 10 divided by 2, which is 5. To this you add 5. So what would be the value? 35.5. So you have two methods to find the mid value. Okay. So after doing these two changes, now my table will look like this. Please join with me here. I'll have marks as one heading. Okay. And another heading, number of students. So what's the marks now? It's not 0, 1 to 10. Instead, it's going to be 0.5 to 10.5. 10.5 to 20.5. 20.5 to 30.5. So on. Probably you can fill the others. Last one will be 90.5 to 100.5. Number of students is 3, 7, and so on. You can fill this one. I cannot take this as my x value. Actually, this is my x value, but I cannot use apply in the formula. Instead, what I do is I add a column for m value. Let me add over here itself in red color, m value. So this m value is 5.5. Am I right? See, between 30.5 to 40.5 is 35.5. So between these two will be 5.5. You can check with the formula again if you want to. This will be 15.5. This will be 25.5. So on. The last one will be 95.5. See, all the spreader of the value is same only. It's even class intervals. You agree with me? Now only we check 10, 10, 10, 10. So the mid value will be same. Instead, if it is given as 0 to 40, 40 to 60, 60 to 90, and 90 to 100, if this is the class intervals given, what would be a mid value? What would be a mid value here? It will not be the same. For each and every interval, the mid value will be different. What's the mid value over here? How we find the mid value? 40 minus 0 or 0 plus 40 divided by 2, which is 20. Next one. 60 plus 40 divided by 2, which is 50. Likewise, next one. Next one. 60 plus 90 divided by 2, 75. Next one. 90 plus 100 divided by 2, 90. See, the mid value will not be looking similar. Here, the mid value was similar, right? 5.5, 15.5. Why? Because all the class intervals were uniformly spread over. But what happened here? Here, what's my class interval range? What's the width of the class interval? Here, 40 points. Here, 20. Here, 30. Here, 10. It's not even. If this is not even, I cannot directly take the mid value as it is. I have to calculate for each and every class interval. It's quite an important one. So I have done with 2 steps. These are the 2 basic steps you have to follow for each and every problem. If it is given in continuous model, then you can proceed for mean, median, and yes, please make a note of it. So as usual, we're going to find everything. Under mean, all the 3 means, under positional average, median, quartiles, deciles, and everything, and everything. Okay. So first let us go for mean, and under that arithmetic mean. You remember the individual observation formula? Summation x by usually small n. For discrete, summation f into x. Why this f? What do you mean by frequency? How many times x is repeated? If it is repeated once, I can directly take summation x by n. If it is repeated more than a few number of times, so when I go for repetitions, I have to multiply. That's why we have f. Okay, so this is divided by actually summation f, but instead we'll have it as capital F. Okay, then for continuous, instead of x, we will introduce m. What's the difference between x and m? X is that exact value which will be available in discrete series. But in the case of continuous, it is given in intervals. Anyway, I'm going to focus on the central value only. That's why directly what I'm doing. For each and every interval, I'm taking the mid value. Okay, so instead of x, I take m. So summation fm divided by capital N. Okay, so this is my formula. So I'm going to find x bar using this formula first. And apart from this, we are going to find one another formula which is called as indirect method. Okay, indirect method. Also is called as step deviation method. Also is called as assumed average method. Okay, assumed average method. Tell me, when I say mean, is nothing but a measure of center tendency. So my value starts here 0.52. So if I go like a line here, you tell me 0.52, 10.5, 20.5, 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, and 100 point. Okay, 100 points. So it's going to be a central measure, right? Tell me where it's going to lie. Somewhere over here. Am I right? Leave off this one. The both ends. Leave off this one. Leave off this one. Leave off this one. So ultimately it's either over here or over here. Sorry, over here. Over here. Okay. So it's either going to be between 40.5 to 50.5 or 50.5 to 55.5. Sorry, 60.5. I'm sorry. 60.5. 60.5. If this is the mean class, where would be my mean value? I'm just making an assumption. See, it's going to lie in between the center value, right? What's the middle value for this? 45.5. In case if I take that, or if I make an assumption, this is the class interval where the mean value will be lying, then what will be the assumed value it may be? 55.5. That's why it's called as assumed average mean method. What's the heading for this? Assumed average or assumed mean method. Because I'm going to make an assumption that this may be the value. So for example, if I take this may be the assumed value A, but this may not be the assumed exact mean value. I'm just making an assumption. So with this assumed value A, what I'm going to do here, I'm going to find x bar, which is equal to A plus summation fd by n into C. I'll explain you why I'm getting this formula a bit later, not now. Okay, let me finish off the problem. Actually, if I take A to be the assumed mean, is that going to exactly match with my correct mean value? Need not. So there may be some plus or minus deviations. That plus or minus deviations are taken from this concept. Okay. So first what you're going to do here is you're going to find arithmetic mean using this formula. Then we'll do with help of this formula. Yes, please. You can start from this one. So you can have the heading as mean, arithmetic mean. This is method one called as direct method. This is method one called as direct method because we are not doing any indirections at all. Directly we are going to use the formula. This is what you call as the direct method. Then we'll go for second method. This is method two. Yes, please. So you're doing using method one means you can join with me. For method one, the formula is x bar is equal to summation fm divided by capital N. Capital N is nothing but summation f. So the total of all the summation value is 90. Okay. I need to find f into m. So let me add a column for f into m, which means multiply f and m. That's you're not going to do anything extra, just multiply. So this value is going to be 16.5, 108.5, 331.5, 603.5, 546.0, 555.0. Am I right? Yeah, 524.5, 524.0, 524.0, 604.0, 513.0 and 573.0. So I think the total is 4375. Is that right? So you just directly substitute over here 4375 divided by 90. So you're getting the value as 48.61. Make it to two decimals. 48.61. So you got the x bar value. Okay. Is it okay? Shall I continue? Yes, method 2. Please join with me. What's the formula for method 2, Pa? What's the formula for method 2? X bar is equal to A plus the deviation. Okay. Let me explain what we are going to do with this deviation. What's the X bar? We got it now. 48.61. In earlier discussion, I was saying that my mean value will be lying in this class interval. So I can take the assumed mean as 45.5. You remember? I can take the A value as 45.5. So let me have it as 45.5. Is both same? No. This is my exactly calculated X bar. This is my assumed value X bar. So I cannot use X bar. That's why we are using as assumed mean A. So there is a difference between these two values, and this difference is calculated using this deviation with the help of what? Formula. Summation fd divided by n into c. Whenever we talk about the small d, wherever, see, we know this n is nothing but size, cardinal number. Small d is nothing but deviations. Okay. This deviation is taken from where? X minus a. Where is this deviation taken? From my assumed value. What's my assumed value? X minus 45.5. If I take everything in decimals, it will look like a big calculation. That's why what we are going to do here is, see, everywhere I find that 0.5, 0.5, 0.5. See, X is nothing but M. Sorry, I have to take it as M. Everywhere I find 0.5, 0.5, 0.5, right? So I divide by 0.5 throughout. Okay, this one I can do it. Else, what I can do is I can divide throughout by 10. See, what's the difference? 10. I can divide throughout by 10. These two methods are used, but usually what we do is we just divide by 10. Okay, we just divide by 10. Please remember, after taking all the deviation, which method or which measure is the best measure means arithmetic mean is the best measure. So with the help of all the deviation, I apply the formula summation FD by N. Okay. And you find that C is multiplied because here I am deviation, I am dividing by 10. So I have to multiply by 10 only. If you are not dividing by 10 here, you need not have this formula. Please make a note. I can do this in two ways. One is summation FD by N into C. Here in this case, D will be X minus what? Not X, sorry. M minus M minus 45.5 divided by 10. Why you have to divide by 10? Because you are taking C. In case you are not taking C means what you have to do? You can directly take summation FD divided by N itself. In this case, D is going to be M minus 45.5 alone. So in case if you want to divide this value by 10, then overall you have to multiply by C over here. If you're not dividing this, don't take it in the formula. It's asked in the exam. So usually I go for this method so you can carry on the same principle. Because you're not going to work out with the full calculation, you have to understand the formula. So what's the formula for? X bar is equal to A plus summation FD divided by N into C. What is this N? Total frequency. Okay, what is this C? Either C or sometimes in the formula you may find it as H or sometimes I. It's nothing but width of the class interval. What is that? Width of the class interval. What is this 10 value? Because of this difference, right? The class interval width. This is what you call as the width of the class interval. So you can directly add one column for D. Can please join? Add one column for D, which is equal to M minus 45.5 divided by 10. So can you find the value? Is one value will help you out. What is M? 5.5. What is the other value? 45.5 divided by 10, which is minus 40, which is minus 40 divided by 10, minus 3. Likewise, if you go for the other value, you'll get minus 3, minus 2, and so on. Yes, please try. Minus 3. Yes, you can directly tell the value. Minus 3, minus 2, minus 1, 0, yeah, 1, 2, 3, 4, 5. Then you add all the value because we need to get the summation. Add all the value. Minus 4 plus 4 will get cancelled. Minus 3 plus 3, minus 2 plus 2, minus 1, 1, 0. So 5. Please apply the formula. Oh, sorry, I had to multiply. Sorry, sorry. Thanks for correcting. Okay, I have found D alone, right? I need to find F. Thank you for. So F into D. What's the value for? F is here. This is minus 12, minus 21. Yeah, minus 26. So, minus 17, 0, 10, 16, 24. Then I think 24 again and 30. What's the value? Summation FD. Check whether you're getting 28. Mhm. So let me apply the formula. Here A is 45.5. So X bar is A plus summation FD divided by N into C. So here it is 45.5 plus, yeah, 28. 28 divided by 90 into 10. Am I right? 45.5. I want to have this value, please. 0.31. Exactly. If you add, you'll get 48.61. Correct? Into 10 now. Okay, into 10. Okay. So this is 3.1. 3.1 or 3.11? Make it for so make it for two decimals because I want to have the exact value. So if you add, what you get? Getting 48.61. What was the original value when calculated using the first method? 48.61. See, actual value is 48.61. Because we used this assumed to mean method A, we used it as 45.5. What's the value we are getting? This deviation 3.11. Instead, if I take the value A to be 55.5, you may ask me why I have to take 55.5. I exactly don't know whether my mean is going to lie over here or over here because I have two class centers in the middle. I don't know whether it will lie over here or lie over here. I thought it might be lying over here, so I thought 45.5 can be taken as assumed mean. If it lies over in this class interval, then I'll be assuming 55.5. So now let us check what happens if I take 55.5. Before working over the full problem, what actually I had to get? What's the formula? X bar is equal to A plus summation FD by N into C. What's the D value here? How you calculate? M minus 55.5 divided by 10. Yeah. What was my original X value? X bar? Here I am assuming. So what I have to get here? Take the help of the calculator. Tell me. I want exact two decimal places. Take the help of the calculator. Just reverse it. If this is X, what you will do? X is equal to minus X is equal to 55.5. So how you find this value? Just reverse it, right? See, what is this X? How you find it? 48.61 minus 55.5 is X value, right? Am I right? What's the value? Plus or minus? That's the value I want. Just take the help of the calculator. That's it. Tell me. Minus 6.89. Exactly. I'm taking for two decimals. So if you take 55.5 minus this value, you will be getting 48.61. Now, the same method how we worked out here. We found D value and FD. D value was found using 45.5. Now you use D value as M minus 55.5 divided by 10. Then find FD. We'll check whether you're getting this value. Yes, please do it. So you might have got this value to be a negative value. Am I right? That's why you're getting a negative sign. That's why when you subtract it from 55.5, you're getting lesser value, 48.61. So tell me, because of what, actually, if I go for the formula, X bar is equal to A plus summation FD by N into C. Kindly join here, everybody, please. This is the formula. In the formula, I have positive sign. Plus. But when I take this as my A value, that is 55.5 as the A value, I'm getting a negative value. Okay. Here, in the first case, 45.5 is A, which I have to add 3.11, then I'll get the original 48.61. Whereas if I take 55.5, I need to subtract. And obviously, you might have taken the full calculation and you found this value is negative. What was this value? What was this value? This full summation FT value. Minus, you're getting a negative value. In the formula, I have plus but I may get a deviated value, and this deviated value is because of n. This minus is because of n. Please try to join here. We can do it later. I'm getting a negative value here, right? Is this negative value because of n? What is n? The total frequency. N will be never negative. It's going to be a positive value only. Is this negative value is because of C? Never. Because what is C? The width of the class interval, that is never going to be a negative value. What do you mean by width means size? That's never going to be a negative value. So that's also a positive value. So only the negative value is because of what? Summation FD. So summation FD is negative, we are getting a negative value. Summation FD means F and D multiplied. Correct? Then take a summation. Now tell me, F is going to be a negative value? F is a frequency. It can never be negative. So it's going to be a positive value. So which will be the negative value? Deviation. So what is deviation? M minus either 45.5 divided by N or either 55.5 divided by N. Depends on whatever you take, you get the right answer. Now tell me what's the nature of D here? It can be either negative, it can be positive, it can be zero. Because of this impact only, what you got here? Positive in one case, negative in one case. Let us go for other case. Let us try this one. Okay. With the same formula, x bar is equal to a plus summation fd by n into c. Here I'm going to take a value as 48.61. Will you try? Your mind voice. Yeah, ma'am, try பண்ணோம். Already x bar 48.61. A plus this value has to be either positive or negative. This value is 48.61. I am taking the assumed to be 48.61. So this value is going to be 0, which is what? Summation fd by n into c happens to be 0 only, then I'll get the same value. Okay. I know that C is never going to be a zero value. What is C? Width of the class center is never going to be a zero. N, not zero. F, not zero. Ultimately, A has to be zero. So you need not work out. Okay, please try to understand. So what's the nature of D? Either it can be negative, positive, or zero. Okay, so this is one point you have to take a note of. Second point, how the deviation can be taken. D can be taken from m minus a divided by c. What is the c? Width of the class interval. Or you can directly take d is equal to m minus a. If you take d is equal to m minus a divided by c, then the formula will have an impact where it will be a plus summation fd by n. Because you have divided by c throughout, you have to multiply. In case if you take d is equal to m minus a alone, then x bar will be equal to a plus summation fd by n alone. You will not multiply by c. Please make a note, okay? And please be understood that this is the first thing you have to perform, then adding. You should not do that a plus summation fd by n. Finding all this you have to multiply by c is wrong. Because in some questions, all these direct values will be given. Where summation fd value will be given. For the following values, summation fd, n, a, and c, will be asked to find x bar. How will you find it? In case summation fd is given, I think it's minus 62, the last case. N is given, which is size 90. A is given, which is 55.5. C is given, which is 10. You are asked to find x bar. How will you find it? A plus summation fd by n into c. Yes, tell me. 55.5 plus minus 62 divided by 10 into, divided by 90 into 10. So what are you going to do here? What are you going to do here? Tell me. You're going to do this one? No, it should not be done. Which one you have to do first? This one. Then this one. which means 55.5 is the the board mass rule, right? Addition will be performed last. Here there is no bracket, but already in our earlier discussion, we were discussing in this way. Remember, this is a complete set containing this one. So what you have to do here, first you have to find, substitute, what is the summation? Minus 62, minus 62 divided by 90. You got some value there. Then after that you multiply by 10. Okay. You got some value there. Minus will get it. You'll get it minus. After that you add 55.5. This is the method part. Please focus on this. This is the method. இல்ல மேம் நான் வந்து -62 × 10 divided by 90 பண்றேன் மேம். ஆனாலும் அதே வேல்யூ ஒன்றும் பிரச்சனை இல்லை. மல்டிபிளிகேஷன் டிவிஷன் ஒன்றும் பிரச்சனை இல்லை. But here you have an addition. You should be very careful. So if you use the board mass rule, first brackets will be given importance. No brackets, then leave it off. Multiplication will be given importance, then only addition. So this is the formula. You have to focus on this. Often repeated question. I'm just trying to find in the page. Over here. What is the different name we have used? Assumed mean method, which means I'm using or taking the help of A. Okay. It's also called as step deviation method because we are finding D and deviating step by step by step. So step deviation method. It's called as indirect method. We have the direct formula x bar is equal to summation f by n. Instead of using the simple formula, we are complicating ourselves. Okay. But if you have a small interpretation, which method? Method 1, direct method. Method 2, indirect method is better, which means indirect method is better. Method 2 is better. Because with the help of this formula, we are going to find median and mode. With the help of this formula, I cannot do further. But with the help of the deviation formula only, we are going to find median and mode. Okay, if you want to make a note of anything, yes, please go. So probably you might find the workings over here. Second heading, to find median. Usually what we do? In the case of second heading, to find median. In the case of individual observation, what we do? We need to arrange. Then how we find it? Formulate. Size of n plus 1 by 2th observation. Okay. In the case of discrete, actually we have to arrange, but arrangement is not necessary because already it will be tabulated in arranged format only. Okay. So in the first step we have to arrange it, but not necessary here. Then what we do? Instead of size of, we'll take it as CF greater than capital N plus 1 by 2th observation. Similar like in the case of continuous, first step we have to arrange, but already it will be given in arranged format only. It's a default problem, it will be given in arranged format only. Second step, same like you did in discrete. What's the second step? We will find the CF greater than not n plus 1, instead n by 2 observation. By using this one, we will not find the median value. Instead, we will find something called as median class interval. That will be called as median class. And after that, we take the help of the formula using the indirect method we were discussing in the earlier session. So using the indirect method, the median is given by, what's the indirect method formula over there for mean? A plus the deviation, right? Here, we'll identify the median class. So after identifying, we'll get the class interval and we'll take the lower limit of the class interval, lower limit or lower boundary of the class interval. That value will be mentioned as L. So instead of A, we'll take L here. Plus, from where you're going to take the deviation. See, this deviation can be done in many methods. Here we used arithmetic mean method. See, what's the formula for arithmetic mean? Sum of all the values divided by n, right? That was the formula we used. We have so many methods, and one formula method is what you call as interpolation method. With the help of that method, again, use this formula n by 2 minus m divided by f into c. You remember what we did over here? Summation fd by n into c. What is this n? The total frequency. But here we'll not talk about the total frequency, because when we discuss about arithmetic mean, each and every value given will be considered. But in the case of median, you're not going to consider the n values, only the positional values you're going to consider. So we'll not consider the full n. Instead, what we do, we'll consider the class interval which is chosen as the median class, and that f value will be only considered. And the numerator is n by 2 minus n, where we know that the value of n is nothing but summation f by 2. So middle value will be somewhere lying in between. Minus m, what is this m is? Cumulative frequency, the preceding value. Cumulative frequency of the preceding median class value. We'll find the median class. Okay. Then we'll find all the cumulative frequencies. Then we'll find m, where we'll get the median class. The preceding median class cumulative frequency will be taken. Let me work out the problem. You can please join with me. So what is the marks? Usually how we'll take the marks? Not the original value. We have to convert to boundaries. Okay, yes, tell me the boundaries. 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, 70.5 to 80.5, 80.5 to 90.5, and the last one 90.5 to 100.5. Okay, then I'll have what's the value? M. What is M? The middle value. 5.5, 15.5, 25.5, 35.5, 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. Then frequency 3, 7, 13, 70, 12, 10, 8, 8, 6, 6. Usually you go for cumulative frequency. So what is the cumulative frequency? Usually when we say cumulative, it's less than cumulative frequency only. Okay, so 3, 10, 23, 40, 52, 62, 70, 78, 84, 90. You have to get the total frequency 90. Yes. So what's my first step? What is my first step? Arrange it. It's already in arranged format. How do you say it's arranged format? See, it starts from 0 to 1, that is 1 to 10, then 11 to 20. It's an arranged format only, no issues. Next step, I have to find the CF greater than n by 2th observation. So what is n by 2? What is n by 2? 90 by 2. Okay. So n by 2 is 90 by 2, which is 45. Then you find CF greater than 45. Okay. So 45 lies over here, right? CF greater than 45. Here is 40. Here is 52. So 45 will be lying over here. Okay. So I have to take the cumulative frequency greater than 45, and corresponding to this, I'll get this as the median class. Am I right? This is my median class. So with the help of this one, I locate the median class, which is given as 40.5 to 50.5. Once you have chosen the median class, you will go for choosing the lower limit or lower boundary of this median class, and this is named as L. Now what's my formula? Yeah, please join. Median is equal to L plus n by 2 minus m divided by f into c or h or I or whatever it is. Okay. Now tell me, what is L value? Yeah, please substitute. 40.5. What is n by 2? What is M? Cumulative frequency preceding the median class. This is the median class. Okay, this is the median class. So preceding the median class means this is the preceding median class. And what is the cumulative frequency corresponding to this? 40. So 40. Okay. Divided by this F is this value. This F is nothing but the class frequency. Class means which class frequency? Median class frequency. So this is divided by 12. And what's the C value? Median class interval. That is width, which is 10. So you get the median value. Yes, please. 44 point. Is it okay? So probably you have to make a note that here we are using a different concept with respect to deviation. Okay. Here, why we use a different concept means we are not worried about the end values, we are worried about the middle values, and we are too much worried about this median class only. See, we say here cumulative frequency greater than 45. We don't know the exact value greater than 45. Can you please locate it where is greater than 45 exactly? 46 also is greater, right? 47 is also greater. But no the go, we are pushed to choose this 52 value. So there might be a deviation with this 40 and 52. That's why we are considering this 12 difference. See, what is this F value? 12, right? Actually, how was this F value received is 52 minus 40. But ultimately, that's the frequency. We write it as 52 minus 40. Probably, you go for the formula table, page number 2.3, 2.3 or 2.2. The very beginning. We'll have two formulas over there. I request you to make a note of both the formulas. Over here. Can you find these two formulas? See, this is the formula we usually use it. L plus n by 2 minus m divided by f into c. Or else we'll be using this formula. What's the difference between these two formulae? If I substitute in this formula, what is n by 2? 45. What is this value I got it? 40. Right? This 40 we are mentioning as NL. Okay. So this is NL. 40. This is the corresponding median class cumulative frequency. 52. 52 minus 40 is 12. That's why you take F as a class frequency. Median class frequency. So either you can take it as Nu minus NL or you can directly take it as F. Please make a note of both the formulas. See, if you are asked to find the median value, you can directly find it. No issues. But if they ask you to mention the formula, you have to be aware of both the formulas. In the first formula, only the cumulative frequencies will be used. In the second formula, we are directly using cumulative frequency and the frequency. Okay, yes, but please. If this is okay now, you can continue with quartiles. Quartile 1, quartile 3, O6, P7 and P75. Yes, P75 or P70? 75. Yes, can you please continue? How will you do for Q1? Instead of n by 2, you take n by 4. How you take Q3? 3 into n by 4. Likewise, same. Yes, make it faster. Here, no need to find greater than cumulative frequency, less than cumulative frequency will be sufficient. Yes, come. So Q1 will be related. So you'll be finding something called as quartile 1 class, right? First quartile or quartile 1 class with the help of CF greater than n by 4th observation. In case if we go for Q3, then you will be using the same thing where CF will be now greater than 3n by 4th observation. Okay. Likewise, we have to do it for O6, D7, P70. Yes, please. So what happened in the case of Q1? This Q1, what you did first? N by Fourth value was found. What is n by 4? 90 by 4, which is 22.5. Am I right? Then you calculated CF greater than 22.5. So this is my CF. So it lies over here. So this is your class named as, yes, what's the class named as here? Q1 class, quartile 1 class. So now what? Quartile 1 is L, the formula L plus n by 4 minus CF preceding that value divided by F into C. Yeah, tell me, what is L? 30.5 plus n by 4, 22.5 minus M, the preceding value, 23 divided by F, 17 into 10. That's right. Oh, sorry, sorry. Okay. Okay. This will be totally wrong, right? So here, this is a median class. Sorry, this is a quartile class. So this is L takes the value 20.5 plus 22.5 minus 10 divided by 13 into C. I'm also checking. See, this is my median class. Means how can the earlier one can be a quartile one class? Okay. Okay. Thank you, Paul. So quartile 3 directly shall I work out n by 4. 3 times of n by 4. 22.5 into 3 value. So this will be your quartile 3 class. Am I right? Quartile 3 class. So what is L value? 60.5 minus 67.5 minus the 62 divided by 8 into C. Did you try working directly with the help of a calculator for the next two values? Or did you try each and every step? Right, right? So tell me, O6. O6. 6n into, so you might have done 6n by 8, right? This value 67 point. Okay. So you'll get the same value for Q3. So this is the octal class also. So you'll get the same value. What about D7? Actually, for P75 also you'll get the same value. D7, 7 n by 10. 63. So greater than this, you're getting same, right? You're of 63 only, no? So you're getting the same here also. So what's the value? L, which is 60.5 plus 63 minus 62 divided by 10 into. So this is the D7 class. So Q3, O8 and D7 everything matches with the same. P75 also. Okay. Okay, so this is about median. Shall I go for next one, mode? Actually, when we talk about median, what happens? Huh? Actually, yeah. What value you're getting? 60? This value. Huh? No, I'm not telling the final value. I'm talking about the D7 class. D7 class is same, right? See, what is 7n by 10? See, I have to calculate D7 means I need to get this value, 7n by 10. What's this value? If this is 63 means this will be your CF greater than 63. Then this will be a design class. Am I right? This value will be different, but this will be a design class. So what is this value you're getting? D7? This is right. I was telling that this will be the design class. Okay. Uh, Actually, when we go for median, let me have a small overall glance. Mean means I'm talking about arithmetic mean. Mean, median, and mode. Under mean, we have two methods, right? What are the two methods? Direct method, indirect method. Under median, we have this formula method. This formula method is taken with the help of interpolation formula, the deviation, how you deviate. Was the interpolation formula. Only once it was asked in the exam. Also, you can do it graphically. This graphical method is given by Ojai. It's called as Ojai curves. We have done that earlier, right? In the earlier topic. So this is called as Ojai curve. With the help of less than CF and greater than CF, we'll draw the curve and we'll find the value. Okay. For mode, what are the methods we have? Usually when we go, we'll talk about location method, we'll talk about grouping method, we'll talk about empirical relationship. The same way we talk about mode. Here, actually, can you do by location method? You cannot directly do the location method and find the modal value, but using the location method, you can find the modal class. Okay. Probably after that, we'll take the help of the formula method. Okay. What's the formula method? We'll discuss. So this is one formula method. And second one, we also have graphical method. Yes. What's the graphical method? How you find mode using graphical method? With the help of histograms. Okay. And third, if you are not able to find the mode particularly, if it is ill-defined, we can go for, see, in most of the cases for continuous, we'll get some value. It will not be like ill-defined. So we'll go for empirical. What is that empirical relationship? Mean minus the deviation, right? So we have to work out for a graphical method, but what I'm going to do here is I'm going to finish mode first, then I'll go for graphs. So we'll do the full problem for histogram, frequency polygon, frequency curve, then also we'll work out Ojai curve, then we'll discuss median and mode graphically. So let me go for mode now. Okay. Mode is quite simple. So let me go for the problem directly. Tell me. Let me directly work out here. Here also interpolation method is used. Just tell me, what's the first step in finding the modal value? You have to find the modal class. Which is the modal class? This is 31 by 240. So this is the highest frequency. So you find the highest frequency. What's the highest frequency? 17. And this is representing the modal class, and the modal class is 31 to 40, but we have taken the boundaries, which is 30.5 to 40.5. Likewise, we did for mean and median. For mode value, we'll take the help of interpolation formula. We'll take L plus, either small l or capital L. How the deviation taken here is numerator by denominator format. This I'll represent as F naught. I'm going to deviate with the earlier value. I'll represent this as F minus 1. I'm going to deviate from the next value. I'll represent this as F1. So I'll take this as major deviation, which is, sorry, this as major deviation, which is 17 minus 13. Let me go for the formula a bit later. Then here I'll take 17 minus 13 and also the deviation between these two values. 17 minus 12 into 10 always. This is what you call as the modal value. Now give the formula here. What's the 17 value? What's the 17 value per? Here is L plus 17 is F naught minus 13 is F minus 1. Okay, divide by 17 minus 13, F naught minus F minus 1 plus 17 minus 12, F naught, sorry, F1 minus F naught into H or C or I, whatever it is. Or we can still further simplify this. You can write as L plus, let the numerator be as it is, and the denominator, see, I have something I missed out. F naught, F minus 1, F1, one second, F naught, F minus 1, F1 minus, We have to take this other way. Please check this one. One second. So this is F naught, F minus 1 plus, what is the 17? It's F naught, right? F naught minus this 12 is F1. Okay. So here, if I do some grouping work, this is F naught, this is F naught. I'll get 2 times of F naught. And what is remaining? Minus F minus 1 and minus F1 is remaining into C. I can do this like this way. Or if you are getting confused with F naught, F minus 1 and F1, what usually I do it is, let me take this as F1, let me take this as F2, let me take this as F naught. We'll go in order. So here I'm taking this difference and this difference. In the denominator, I add it. So this I can write it as modal is equal to L plus, see instead of F naught, I'm taking this value, right? F1. So F1 minus F naught divided by 2F1 minus F1 minus F. This will be like somewhat rhyming like into C. Minus F1. 2F1 minus F2 minus F naught minus F2. F naught and F. Okay. F2 minus F naught into C. Either I can go by this way or by this way. You can use both, but if asked as a formula, be clear which one you have to write. What's the concept behind here is, see in the numerator what we consider. You name it as anything, don't worry. In the numerator, we consider the difference between these two. In the denominator, the difference between these two and these two added. What's the value here? Median class lies over here. What's the corresponding frequency? 17. What's the next frequency? 12. What's the earlier frequency? 13. So here directly you can take modal class is equal to L plus the difference between these two, 17 minus 13, divided by 17 minus 13 already taken plus the difference between these two. Should not take 12 minus 17. Here I take 17 minus 12. This value can never be negative into C. So please fix this in your mind. Whatever the formula they dictate in the exam, take it. Because sometimes the formula will be given as F naught, F1 and F2. Sometimes the formula will be given as F naught, F minus 1 and F1. So accordingly, let me go for a rough diagram. X-axis, Y-axis, scale, everything. Okay. 0.5 to 10.5 is 3, right? So 3. Then 7. Can I get the next value? 13, huh? 17. I think this is the tallest bar. Yeah. Yeah. 12, 10, 8, another 8, 6, 6. Okay. This is histogram. For frequency, polygon and curve, we'll do it later. This is the tallest bar having the frequency 17, right? The earlier one 13, the next one I think 12. Okay. We'll draw the two lines like cross zigzag line. We get like an X, not exact X. So draw two lines. The point where it meets, from there you drop a line to the x-axis and this point will give you the modal value. Okay. So if you have a keen look on the graph, what value you are getting there in the graph sheet? You have that graph sheet working? You have that working? over here. You have the graph sheet. Only these two. Only these two are here. Okay. See here. This is the topmost bar. From here, you have to touch the earlier bar's boundary. Then over here, this is 13, this is 12, this is 17. You remember the formula for modal? L plus numerator 17 minus 13. So you get the difference. This difference. Okay, 4. Here 17 minus 30 plus 17 minus 12. This is interpolation. So this is 5. So 4 plus 5 it will be. The reason why we are considering the reason why we are considering here the difference between the two bars is because of the interpolation method. Interpolation method, if you do graphically, you'll get this figure. Okay. This point you have to make a note of, and this point. Okay. This point you have to make a note of, and this point. Please make some markings. This is the 17 tallest bar. Okay. This is from the tallest bar, the right side point to the right side point of the earlier bar. In the tallest bar, the left side point and the left side point of the next bar has to be considered. Once asked in the exam, that is which point you mark. Okay, somewhat clear, right? Shall I continue? Not yet over. Shall I continue? Shall I continue? Yeah, tell me, what is the uh, class interval for this? Is 30.5 to 40.5. What's the class interval for this? And the class interval here? Sorry. Yeah. So this is 20.5 to 30.5. The question may be like this way, Paul. In this part, 20.5 to 30.5, you have to take with respect to the point lies with 30.5. Okay, let me go this way else. What's the coordinate for this one? What's the coordinate? How you mark the coordinate? X-axis, X value and Y value. How you mark this coordinate? X value 30.5, Y value 12. Am I right? Here 40.5 and 17. Am I right? Here 40.5 and value 13 or 12. Here 12 or 13. Here is 13. Okay. And here 30.5 and 17. So if you have a keen look, you'll find that here is 30.5, sorry, 40.5, here is 13.5. And you have to subtract these two. This is 13, right? Subtract these two. Here is 40.5, here is 30.5, which means you will be subtracting these two values. Okay, please have a keen look. Exam is for the next one. Ujjayi curve. So you might have got a curve like this way and another curve like this way, right? Less than Ujjayi and greater than Ujjayi. Where the two Ujjayi curve meets. From there, you drop a line to the x-axis and this will give you the median value. Okay. So you might have got somewhere closer to 45. What is our value? Using the formula method, we got 44.67. Am I right? So you might have got some value closer to 45 because we are not drawn to scale. We are not using the graph sheet. So you might have got something closer to 45. So where it lies? 40.5 to 50.5. So somewhat in the middle. You got it? So this is the median class, median value. See, with the help of less than CF alone, you can find it, or you draw both less than CF curve and greater than CF curve. Where it meets, we can take it. There are two ways. If you're considering only less than CF, what we do here is we somewhat apply the formula with respect to n by 2. Okay, let me go here directly from single material. I'm not going to work out full problem. Where is n by 2, pa? Where is n by 2? What is n? 90 here. 90 by 2. So 90 by 2, it's 45. So 45 lies over here. Here is 60, here is 40. So 45 lies somewhere over here. Okay. From here, you draw a line to the less than Ojai curve. You meet the Ojai curve here, then drop down here. You'll get the value, and it's approximately 45 I have taken. This is Q2. You can correct it. 45 I have taken. See, I have not drawn to scale. That's why. If they are asking, so this is with respect to median. If they are asking with respect to quartile 1, what value will take? N by 4, right? Which is 22.5. In the y-axis, find 22.5, somewhere over here. Okay. Draw a point. So draw a line so that it meets the less than Ojai curve. Then from there, drop it. We'll get the approximate value only. So what value we got by calculation? It's 30.12 we got using the formula method. So here it's somewhat closer to 30. Okay. Q3, yes, please. 3n by 4, which is 67.5. So over here, from here, draw a line so that it touches the less than Ojai curve. Then drop down the line to x-axis and you'll get the point where it is roughly 67 by formula method. We have got this as 67.38. Can you guess D7? Because P75 will get the same value, O6 will get the same value. Can you try D7 in your material? Please try. Or you have drawn the graph means you can directly mark over there. D7. Where will get D7? So D7 here, 7 into n by 10. What value we got? 60? 63? Okay. So I thought you were telling the final value. 63 means somewhat closer to here only we get, right? Drop a line over here and over here. Let me clean the board. Yes, with respect to D7, 7n by 10, which is 63 here. So 63, this is actually 66 something. So 63 will be somewhere over here. So it will be closer to this. From here, I have to drop a line. Yes, what's the value? Roughly, it will be around 61. Okay. So what's the value we have got? Using the formula method, 61.75. No issues. Okay, probably they may give a graph, and from that graph, you may be asked to note down the values. Okay. Okay. So graphical method over. Next, we have to find the empirical relationship. Shall we check whether the empirical relationship is working? Before that, tell me all the values, what we have done. What is mean? Arithmetic mean. Yes, list out all the values. Please try and make it faster. What is arithmetic mean value? 48.61. Geometric mean? Take it for two decimals always. Harmonic mean? Please check whether this relationship is satisfied. Is it right? Okay. 48.61 greater than 47.01. 07 greater than 32.25. Okay, this is over. Next is median. 40. 67. Quartile 1. 30.12. Quartile 3. 67.38. 06. P75 is all same. D7. Okay, if I draw it in a line, yes, where is median? Over here represents which value? 44.67. Quartile 1 over here. Quartile 3, 06 and P75 over here. And D7 somewhere closer to Q3 but before. Okay, because this will be D7.5. Remember? This will be D7.5. So D7 will be somewhat closer and before that. And what's this value for? 30.12. See, this is lesser. And what is this value? Q3, 67.38. And what is D7? 61.75. Yes, there's a relationship between D7.5 and uh, O6. It will be lesser. We already discussed this. Okay. So this is done. What is mode? Yeah, mode 34.9. So we have found all this empirical relationship. We'll check. What is empirical relationship? It's a thumb rule. Thumb rule means 99.9999999% it will work. Which means what? 0.0000 somewhat 1% will not work. Right? That's what thumb rule is. It is not 100% true. So what's the thumb rule? Sorry, what's the relationship? Yeah, please. Mean minus median, mode 3 times mean minus median. We'll check. What is x bar? Usually we take arithmetic mean as x bar. 48.61 minus mode 34.94 value. This value directly. 13.67. Always keep for 2 decimals. Don't write off. Is it right? This side. 48.61 minus median. 44.67 value. Final value I want. Getting 11.82. See, it's not matching. So always it need not be true. It may be sometimes false. This also asked many times in the exams. So measures of average is over. Measures of dispersion, I request you to do as an assignment. Value substitute பண்ண வேண்டியதானே பண்ணிடலாம். Okay. So you can take it as an assignment. All the values, absolute value, relative values, everything. Okay. Please join. I request you to highlight this word, a representative value. Whether it's a mean, median, mode, any quartiles or deciles or whatever, any positional average. We take this as a representative value. Okay. Please make a note of this illustration. We have the x values and f value given. See, how's the f value? 1, then increases 3, then increases 7. It reaches its maximum. Then what happens? Decrease and reaches its minimum. If you draw frequency polygon for this, your graph will look like this way. Am I right? I request you to make a note of this word. It gradually increases. We remember in the case of discrete series, we find that it was like 2, 8, 20, that suddenly jumps to 100. That's not a gradual increase, that's a sudden jump. So usually it should not be of this format, which means it says it's not ready. So it will be minimum at the ends. Then what happens? Gradually increase. Here, gradually decrease. At one point of time, it will reach the maximum value. So if you draw a frequency polygon, your graph will look like this. You remember we have this type of graph, frequency polygon. This type of frequency polygon we have this type of frequency polygon, we have this type of frequency polygon. Where did you learn this one? Earlier topic now. Okay. Come back for the earlier topic. Yes, please join here. Frequency polygon or frequency curve. Bell-shaped curve. See, this is the graph. U-shaped curve. This is the graph. Come back here. J-shaped. Umbrella stick. Mixed curve. See this one? Okay. Bell-shaped. See this one? U-shaped. See this one? That's it. Things to be noted. How many mode you will have here? Single mode. What do you mean by mode? The peak of the curve. Single mode. U-shaped. You may have single mode or sometimes bimodal. No trimodal. Trimodal means what? You cannot have two equal points, right? This is bimodal. In case if you have your graph as this one, this is also U. But here's the peak value. Unimodal. You can have a note on this one. This is unimodal U-shaped curve. This is bimodal U-shaped curve. We may have two modal values. Okay? Okay? Shall I take over? Shall I take over? J-shaped. See? Here it cannot take a big value, which means here it cannot extend. So ultimately this will be the peak value. So this will be the modal value. So it's unimodal. What over here? It can meet over here. Actually, it can be unimodal or bimodal also. But most of the time we say when it's a mixed curve, it will be bimodal. Because when we say it's a mixed curve, all the curve plays the role. So this also will play the role, which means it will be unimodal. So it's very rare that you'll get it. Usually we get this way. So usually we say it is unimodal only. Oh, sorry, bimodal only. Okay. So I can go this way. So you can draw this graph from unimodal model and this one as bimodal model. Because you can have all the graphs put together. Okay, please make a note of it. So other things are not we have completed. Directly you can go for results. Please come over here. You can place a star mark, it's quite important because we are not going to derive, we are just going to list it out. If you have any two numbers, what will be the standard deviation? Standard deviation will be modulus of A minus B divided by 2. It's modulus value. Usually standard deviation will not have the modulus in definition, but if there are only two values A and B, you can take it as either A minus B or B minus A because you're going to consider only the positive value. So modulus of A minus B by 2. This is asked with the help of numbers given. A value is given, B value is given. You will be asked to find standard deviation, or sometimes the formula itself is asked directly. Okay, first problem, sorry, first result. Shall I take over? Second, if first and natural numbers are given, okay, what would be the standard deviation? For example, first 10 natural numbers means 1, 2, 3, up to 10 is given. First 10 natural numbers. So what's the value of n? 10. How you find the standard deviation? Substitute in the formula. Root of n square. 10 square minus 1 divided by 12. That's it. So root of n square minus 1 by 12. Is it okay? Third, Cauchy range. Please highlight. It's not quartile deviation. Okay. It's not interquartile range or something like that. It's Cauchy range, which means you take the second highest observation and the second lowest observation and you less. You remember the first problem, 48, 24. What do? You do the arrangement. 24, 48. What's the Cauchy range? 24 minus 6. Okay. We have to be keen on this word, range, not deviation. Cauchy range. Okay. Second highest observation minus second lowest observation. See, this is the highest, right? 48 is highest. Second highest is 24. What is the lowest one? 3. Second lowest is 6. So this is 24 minus 6. Is it okay? Then already we have done this one. You remember? For the population and for sample, For size, we represent as capital N. Here we represent as small n. For mean is x bar here. Here it is mu. How you pronounce this? Mu. Cat sound. Mu. Okay. Here standard deviation. Small s sigma. The analysis what we follow here is called as sampling. So sampling errors and all these things will be covered. Here is complete enumeration. Complete as we believe everything in detail. You go to a hospital. Okay. You say headache. You say chest pain. Everything. The doctor says, I'll do only sampling treatment only. Only 5 will be picked and the treatment will be given. Will you go to the doctor? Okay, what do you do? You change the doctor. Complete enumeration. When you go as a patient, the complete details has to be taken. Okay, along with that, your parents' history also will be asked. Okay. Standard score. Standard score is the number of standard deviations. Please highlight. Usually we take the deviation from where for arithmetic mean. But here what we do is we take the deviation from standard deviation. See the formula x minus. Usually we take x minus x bar or we take x minus a. Here what is done is x minus u. See, instead of x minus x bar, we are taking what? X minus mu. What is x bar? Sample size. Mean. What is mu? Population. Divided by sigma. This is a standard score. Okay. Desired range, you remember? D9 minus D1. Percentile range? P90 minus P10. You should not write this as P99 minus P1. Please write this one and strike it out. It's not P99 minus P1. Instead, you have to take this as P90 minus P10. Okay. Comparison between the measures of dispersion. See, you take the standard deviation value, you multiply by 4. 4 times of standard deviation. You take the mean deviation value, you multiply by 5. 5 times of mean deviation. You take the quartile deviation, multiply by 6. So you get 6 QD. So all will be equal. We can remember 4, 5, 6. Standard deviation, mean deviation, quartile deviation. All this will be equal. Now I want to have only the relationship between standard deviation and quartile deviation. Which means what? 4ST is equal to 6 QD. I want QD alone. What you can do? 4 by 6 ST. This is nothing but 2 by 3. So you got it. I want the relationship between mean deviation and standard deviation. So what you can do? 4ST is equal to 5 mean deviation. So I want mean deviation from standard deviation. 4 by 5 standard deviation. So in the question, if standard deviation is given, you are asked to find mean deviation. Yes, you can find it. Standard deviation is given to be 0.8. You will be asked to find what is mean deviation. What's the value of mean deviation? 4 by 5 of 0.8. That's it. They are giving you quartile deviation as 0.63. They are asking you mean deviation. How you do it? How you do it? See, there is a relationship between mean deviation and quartile deviation. See, 5 times of mean deviation is equal to 6 times of quartile deviation. You know this value, 6 into 0.63. And this is 5 into mean deviation. So how you get the mean deviation? 6 into 0.63 divided by 5. That's it. So you just don't remember all these things. Just remember this one alone. 4ST is equal to 5MT is equal to 6QD. That will be sufficient. You don't remember everything. Memorize பண்ணிட்டு போகணும். ஏன் கஷ்டம்? தேவையில்ல. And please remember this relationship. Standard deviation will be greater than or equal to mean deviation. Okay, please remember this one. So you need not make a note of everything. Probably I'll clean the board. You just remember these two alone. Okay, this one you please remember so that you'll get this one and this one. And you please remember the relationship between standard deviation and mean deviation. Okay. Shall I take over? Ninth one. Standard deviation can also be written as 15 by 8 square root of mean deviation into quartile deviation. Okay. If given two values x1 and x2, how you find geometric mean? How you find geometric mean? Square root of x1 into x2. Instead of x1, we have mean deviation. Instead of x2, we have quartile deviation. So now what's the geometric mean formula? square root of mean deviation into quartile deviation. For this value, you take 15 by 8. You get standard deviation. No need to go for derivation. No need to go for proving and all. You just take it for granted. If it is asked, we need to do it easily. Because if it's a direct question, they'll give you a standard deviation value, mean deviation value. They may ask quartile deviation, the reverse method. Okay. 10th one I'm not discussing as of now immediately. I'll keep this pending because I have to go for normal distribution. As of now, I'm not discussing. Mean deviation, the other name is also called as average absolute deviation because you're going to take absolute value. Alternate formulae for median, yes, we have done these two. Okay. Actually, okay. Alternate formulae for median is usually what we do is we take cumulative frequency greater than n by 2, right? This is the other way where we take the less than n value. The earlier value will be taken. So you need not worry. You can just strike it off. You need not worry. And for unequal class interval, you proceed with original frequency itself. Why is this point taken? Why is this point taken? Any guessing? If a table is given, I'm going to take frequency only. But what is mentioned here? For unequal class interval, proceed with original frequency. What does it mean? When is given unequal class interval, what do you do? Huh? Class? I'm not talking about class limits or class boundaries. I'm talking about frequency. Class boundaries are given but are unequal. That's for median. See, only for median we'll talk about. Only for positional average we'll talk about cumulative frequency. You can turn to the earlier topic. Probably it will be in last 3 or 4 pages. Please check page number 1.16. Answer. Answer is there in page 1.16. What page is this on? Frequency density. What do you mean by frequency density? When we use frequency density, if we have unequal class intervals. If we have unequal class intervals, you have to use frequency density. But from this point, it suggests that even if you have unequal class intervals, you need not go for frequency density. You can directly go for original frequency. Okay. So when you use frequency density then, see if it is unequal means the spreading off is not even. That's why we have to go for frequency density. But the point here suggests even those unequal class intervals, we directly proceed with original frequency itself. Then why we need to use frequency density? Again, go for that page. Below that. What's the point given? Can you find frequency density? Over here. Let me finish off, then I'll come for 1.14. Over here, what it says. In the case of histogram, when you go for graphical representation, you cannot use original frequency. What you have to do? You have to go for drawing frequency density. This was asked once in the exam. The picture was given and they are asked to find what is wrong with the picture. Interpretation question. Okay. And see, for frequency polygon, we have to draw the midpoint only if we have the common width. Okay, so here also is used. You said page number 1.1 for above. There it is. Okay. Okay, fine. So if unequal class intervals are given, what you do is you proceed with the original frequency. You need not convert to frequency decimal. Only for histogram, you have to convert it. Okay. Okay. Other problems, I request you to take an assignment. So I have given so far two assignments. One is work on dispersions on the four measures, absolute and relative measures. So totally you get eight values. And request you to go for other problems. Try working out all the problems. Okay, first, second, I request to work out all the problems. Fourth one you have done, right? You remember? We're working in detail. Fourth one you have done. Seven, eight. This one also you can try. Anyway, in the next class, I will work out these three. Anyway, I request you to try. 10, 11, and 12, I request you to try. Okay. Anyway, I'll work out. For this problem, we call this as weighted average, where the formula will be instead of summation fx by summation f, will be using summation wx by summation w. You might have done it in goodwill calculation and all in the partnership accounts. So we have to give the weightage. So it's 20,000, 10,000, and negative loss 7,000. We have to give weightage as 3, 2, and 1. It will be mentioned. So what's the value here? 20,000 into 3 plus 2 into 10,000 plus 1 into minus 7,000. Okay, divide by summation W. Should not divide by 3. You have to divide by 6. This is 3 plus 2 plus 4. This is weighted average concept. So the last content pending is this one. Probably I'm not going to discuss this today. I need like half an hour to 45 minutes. So I'll take it in another class. This concept, Carl Pearson and Bowley's coefficient of skewness, also I'll discuss in the next class. So from my side, what are the things pending is I have to discuss the 13 characteristics table. Okay. And under the other problems, I have to discuss problem number 10, 11, and 12. What is coefficient of skewness? These three concepts pending. Okay. That's it for today. Thank you. Thank you.